Okay, welcome once again. In this video, we've already been able to set up the road network, as you can see here in the window. And the difference between this road network and the ones we've been doing before now is maybe probably only having one intersection point. And there was another one we did with two intersection point. But people were requesting for a road network where we can have more than two intersection points, so and of different types. We can see this is a what's it called, a plus intersection, and here we have a T intersection also with a diagonal one leading to the highway. So just something like this. And of this, there is a need to have a traffic light in at every of the points of intersection in this road network. So what we're going to be doing in this video is the introduction of the intersection point. Other than this, the road network itself, this is the chart flow logic on its own. So here we're going to be introducing three traffic lights into this, and after the introduction of the three traffic lights, we are also going to be customizing the traffic light to suit the road network. And after that, we can look into the introduction of the 3D animation and also the optimization of the traffic lights. Just to have a closer look at this, so this is what it looks like. So for the first point, let's introduce the traffic lights, then we can optimize, and sorry, we can customize the traffic lights. So I think let me start from here. I'm starting with this because the setup to this is a little bit easier. Like the customization of this intersection is easy, and same with the diagonal intersection point is also easier compared to the first one where we had to do a lot of customization. So for anyone who doesn't have a good knowledge of the introductory part, you can also always learn it from this 2 points before we take it to the first one. So here you can drag the traffic lights. So you can drag the traffic lights in. So let us go ahead and check out the. So now looking into the properties of the first one are this. Now what we have here is the traffic light, and here we know is it's the intersection 3, because one of the things we need to do is to be able to name each of those intersection points. When I click on the first one, this is the intersection 1. This we have the intersection 2, and here we have the intersection 3. Like I said, we're starting with the third intersection, and now we've been able to introduce the traffic light, but we also need to specify that it is for the intersection 3. Now that that has been done, let's change the duration. So the duration will be for, let's say, 20 seconds, and here also 20 seconds. Then we can introduce high yellow lights. You can have something like this. So to customize this, you can, when I click on this, it shows this is green. I can also make this, no, you can also make this green, which shows that when both of them are green, there is movement around here. So then this will only be the one that is red. So when this changed to red, then this becomes green at this point. So it becomes green. So, but this is still under the defines the mode for intersection stop line, because that is what we're using for this traffic light, and we're also going to be using the same thing for the diagonal traffic light. We'll only use the intersections lane connectors for the first traffic light we had, because it has this T intersection, just to show the different ways in which we can set up the intersection. So like what we can see from here, I think we are done with this. This is the traffic light 3. So we move to this next one, view the properties. So this can be traffic light 2. And the same thing also, we introduce. So let's put this maybe also 20 seconds. 20 seconds. So we set this up also by doing the same thing. Yellow and green, then this should be red. So when this is green, this and this can be red. So at this point, only this is green, but at this point, both of them are green. So we can set it up this way. So this is traffic light 2. I think that is all. Then we proceed to the first part of it here. And we can proceed here by trying something different. We could have also used the same method in which we used for the first two traffic light for this one, the customization. But let's just try something different at this point by using the link connectors this time around. So we are already on the, so that means we need to introduce the traffic. After introducing the traffic light, let us customize the properties of the traffic light. We know this should be traffic light 1, which will go for the intersection, the first intersection. And here we're going to be using the lane connectors. The moment I click on the lane connectors, it will show all the possible lanes we have on that particular intersection. So which is this. So let me move this one here. Shows all the possible lanes we have. So these are all the possible lanes. These connections we have here, they are all represented here. They are all represented. So this one is a little bit much more realistic compared to the first two we've done, because it pays more attention to every connectors. For the first two traffic intersection in customization we did, when we try to use that in real life, we might have a little problem with that because of the movement of the vehicles compared to what we might be doing at this point. So at this point now, if I click on this, it shows the right turn lane. So that means we can have movements from the north to the south. Let's set up the ones from the north to the south. No, so this can't be. This can be. No, no, no. I need a true lane. No, no, the true lane. Yeah, we do the same there too. Set up another true lane, then set up another true lane. So these are movement of vehicles going in this direction. No. So in a nutshell, when it comes to these 4 points, there is always movement when it comes to those 4 points. So I haven't introduced our yellow lights. So we can decide whether we want to set up 3 faces or 4 faces. So it depends on what we hope to accomplish. But I think let's just set up 4 faces. So that means I can establish one more. Then so so we put a yellow light in between. Set this up in between this way. So this we've been able to set up for the first phase, and we're still doing for the second phase. but I'm just setting up the those constant faces that are always moving. Okay, so let's make room for one more, like we agreed. Then after that we have this one. Okay, so now we have four faces: phase one, phase two, phase three, and phase four. So for all the faces, the right turn lane is always active. We keep the right turn lanes active. That is what I did to the four of them. The right turn lane is always active. So since the right turn lanes are always active, now for this first one we're doing here, the movement from the north to the south and from the south to the north is what we did here. So that means at that point, that is the only movement we have. So in the second phase, then we can have the left turn lane. So that means when every other thing are red, then we have the left turn lane. So that is coming from here this way. So if we have that the left turn lane that way, we can also have it on this other road going that way. So since we have two of them, we've been able to establish that no, it will. We can also do that. We can't. No. So if I don't want to keep doing this by clicking, you can just come in between, then click on it to enable it. So since we're on the second one, so I've been able to enable it here. You can see it's already enabled. So that means the movement from this going here and also this with the right turn lanes, the left turn lanes for those two aspects. So since we've been able to establish that, also we move to the other part, which is we've been able to do this then from the west to the east. No. Okay. Let's just we can also decide to take up the other. No. So but here I know this should be the right turn lane, the west to the east here. So like we said, what we're trying to establish being able to make, so that means this can be green, and this will also be green. So being able to establish that both of them are green at that point. So that means somewhere around here they are green. Then for the last part is when they from the west road to the east road and the east road to the west road, when those parts are green. I've been able to establish for two of it already, so let me just click on this to establish that, and also this one also to establish that. So being able to establish for all of them, then we increase the durations. We want all the durations to be 20 seconds, 20 seconds, 20 seconds. So at this point now, that means we have four faces. So which in total puts all the total faces of this road network to eight. Four for the traffic light one, two for the traffic light two, and two also for the traffic light three. That makes it eight faces in total. So in the previous traffic light optimization we did in the on the platform in which if you've come across the video, we only had four faces, that is of two different traffic lights, two for each of the traffic lights. But now we have eight. So that means when we're drawing up our parameters, we won't be having four parameters like the way we had for the previous one. We're going to be having up to eight parameters this time around. So now that this has been established, then we can close this. So you can decide to run the simulation to see the behavior at the point of intersection, since we've been able to introduce the traffic lights. So we can see the activation of the traffic lights. They will active. See here is green, red, and you can see the movement of cars at each of those points. So if I decide to speed this up, I think we are going to be having more introduction of vehicles into the layout. So So at this point, we're going to start with the optimization of the traffic lights. And in order to do that, the first thing we're going to do is the customized car type into the model. And how do we do that? There are two ways in which we can do that. We can decide to come on any of the castles we've been able to create. You click on it, check out the properties, then you use that to create. From here, we have create a custom car type. You can click on that. So after clicking on that, we have something like this. That is, create the engine agent type from scratch. You click next. So the type of vehicle, yes, you can click on next. Then we had new parameters. So this is very important. So we have the parameter start time, because we want to know the time at which the vehicles are being introduced into the model and how long it stays there. So, and the time value will be, the value will be time. So we have the start time, then this is the value. Then after that, we click on finish. So before we know it, the the card type or the custom card type will be introduced into this model. Then afterwards, the next thing we're going to be doing is to bring in the agent. Let's just give it a few seconds for the for it to be introduced. Okay, so this is it. You can see the time, then the start time. So that has been established. That has been established. So like I said, we'll be able to create the agent, that introduction of the agent. So we come under, we have the agent here, we click on it. So we have here. So here we have the population of agents. We click on this. So at this point, we can decide I want to create a new agent or I want to use an existing agent type. So since we've been able to create a card type, we can just click on I want to use an existing agent type. We click on next. So this is what we have next. We still have every of the informations. Click on next. Then the start time that we created is still there. We click on next. Then we have create initially empty population, and we had agents at the model runtime. So this, then we click on finish. So we can see at this point the agent has been introduced into, this is the agent now. It's been introduced in. Yeah, we now have our agents in. So what we're going to be doing next is under each of the castles, we have to change it to the card type we have been able to create. What am I saying? So we have the first one here. So what we have initially was just an agent, but now that we have been able to create a card type, we need to be able to change it. So here, so we have it as scan now because this was the one we used to create it. So clicking on the next one will still be agent. So it's still an agent, so we have to change it to the particular one we've been able to create. So the next one also, we do the same, change it to car. So we basically change all the car source from just the agent to the particular agent type we've been able to create, which is what we represent as car. Here we have for the last one. So the last one, change to car. Okay. So been able to change all the car sources into the new car, which is the car, the custom car type. So also under each of the car source, I think I actually forgot to do that. So after changing it to car, then the next thing is under the we are meant to change it to the custom population since we're making use of the custom population. So rather than the default population of root agent, so what car type are we using here? So we change this to car. So we put it under custom population because that is what we're using, then changes to car. So let me just quickly do the same for the other ones. So here we have it to custom population also. Then that will be car. What happened? This went back. You need to be sure that nothing changes. S2, okay. Okay. S, okay. D, okay. That's fine. So for this also the same thing. Okay. So we have been able to do that for everything. So after that, let us try to introduce our Instagram data into the model, and we can see that under analysis. I think this should be okay. This is analysis. Then we have the histogram data. You can just drag it in. So that is the histogram data. Then we can just edit the so just edit the name to timing model. So we've been able to do that. So also we need to also edit the car itself. On the destroy, we had a set of code to it, which is main dot. We have the time in model. So at this point we have the main dot, the time in the model dot. We had in the word the time and the start time here. So this will be for the setup of the. So then we go back to this. So the idea of this at the end is to be able to record the duration the car will spend, the duration when it comes to the timing the car will spend in the model. So after when we've been able to do this and we've done the coding, let's introduce the histogram into it. Instagram. Okay. So here we have the histogram. So you can edit the properties of this by adding the name and also allowing the histogram to show the mean. So here we can call it timing model. Then under the title also we have it as timing model. So here we have the show mean. We want it to show the mean. In showing the mean, so what color will the mean carry? Here we have it as dark blue, but the other one is deeper pink, so I think it's fine. So we can just increase this to 3 so that we have a line width for the mean. It can be much more obvious. So I think that is it under this. To introduce every necessary element into the model, we've been able to introduce our agents, the histogram data, also the histogram itself. We've been able to do all this. The next thing we are going to do is to, okay, let's try and run the model and see how well the relationship between the timing model and the histogram data and also the histogram itself. So let us try and do that. So here we have the actual vehicles compared to the agents, car agents we're using before. Now we have the vehicle itself, the traffic lights all active, and here it's where we have our chart flow. And at this point, we have the cars coming into the model or the simulation. Yes, there is our histogram, and this is the timing model. So if we allow this to run for a certain time, we'll be able to identify the actual mean. You can see the mean, the minimum, the mean time spent in the model. We have the minimum time spent in the model and the maximum time to spend in the model. So because we did not set a particular time frame, so this will keep changing over time. And since we didn't set a particular time frame, we cannot ascertain the mean number of time, the mean time it spends in the model within a given period of time. So I think that is one of the things we're going to be doing. Is what we're trying to do now is just to show the account, like we have 24 cars in the model. We have the mean, which is about 38 seconds. We have the minimum, and here we have the maximum. So since we have a running model and everything is okay, then we can go back to the home page. And so before we proceed to start building the optimization experiment itself, let us ascertain the stop time like I explained. So we under the simulation domain, then we check out the properties. So here we have the properties. So we have the stop time never. We change it to a specific date, and from the date I have here, so can change this to 08. Then this is the start time. So since we let it to run for 10 minutes, so 1608 2025, 1608 2025. Then this is the start time. Then it ends in 10 minutes. So we have been able to set a particular time frame for the simulation to run, which is going to be for 10 minutes. So the 10 minutes will be enough to go through several cycles, different form of integrations, and all of which. So we have been able to set the time. Let us run the model again based on the time. So without wasting much time, let's quickly do that. So here we have it now. So this will run for about 10 minutes like we said. We already set the time for 10 minutes. So here we have it. We can speed up the process here. So we just have to be a little bit patient for the whole thing to run for about 10 minutes. The 10 minutes, what we have here will be finished. You can see. So at the end of the day, we check our timing. It will be able to give us a certain mean time each spent in the model. How many seconds does it spend in the model? The mean time or the average time is spent in the model. So in order to be able to ascertain that we have 10 minutes since we set the time limit for 10 and it's in the model. So here we are already 70. So now we have it finished. We have the 10 minutes complete and check. So what is the average mean time that was spent in the model? We can see here we have 54.3 seconds. You can note it somewhere, 54.3 seconds. And the minimum time is 10.3 and the maximum time is about 174.3 seconds. So that is this is for the mean time vehicle spend in the model, and this is the minimum and the maximum. So now that we have been able to establish that it takes about 54 seconds, average of 54 seconds for each vehicle to spend in the model, we want to see how well we can now optimize or probably see if we can reduce the number of time spent in the model. And in order for us to be able to do that, we need to be able to introduce our parameters into this model and see, is it possible for us to reduce the number of time each of the vehicle spend, the average time it spends in the particular model. And for us to be able to do that, we move back to a palette and we introduce what we call the parameters. So here we have the parameters. Earlier when we started this aspect and we're working under the traffic lights, in this particular model we have about 8 different traffic light points. If the number of points we have or the number of faces we have for each of those traffic light, like the previous video we made on this platform, we had about 4 faces in total for the traffic light. But in this particular road network we're able to create, we have about 8 faces. For one of the traffic lights, we have about 4 faces. Another traffic light, we have about 2 faces, and the third one, we have 2 faces, which makes it 8 in total. So what it means is that we are going to be introducing 8 different parameters for each of the 8 faces, and by that we are going to be setting a certain number of seconds and running the simulation to optimization experiment to see if it is possible to reduce the time, or maybe probably we might have to stick with the arrangement we had before. So now we are going to be introducing the parameters. Let me put this down. Like I said, we have 8 different parameters, so all I can do is I can just the properties of this. So I can decide to name it P1. Can decide to name that P1. So since this is P1, can also, when we want to create 8 of it, rather than keep creating, just copy this, then P2, P3, P4, P5, P6, P7, P8. So what I did was copy and paste. So these are the 8 parameters in which we are going to be introducing into the traffic light phase. So since we have been able to create all the parameters, so another way that could have been done is for anyone who wants to have a different form of default value, because here we have to set a particular default value in seconds here. So if you want to create a different default value, then you can have it this way, have our P1 created first, then maybe probably the first one might be 30 seconds, the second one maybe 35 seconds, the third one maybe 28 seconds. If we want it that way, you can set it up that way. But if we want to have a fixed default value for everything, you can just set it. Maybe let's just say this is 30 seconds. So, but the mistake I made was I have already created this. So if I decide to take this out, let me delete so that the default value can range for everything. So we don't have to keep creating the 30 seconds, adding 30 seconds to all the parameters again. So now copy. So here we have each and every one of them. If we want to confirm, pick any one of them, we'll say we still have it as the default value is 30 seconds. So with that being said, after creating our parameters, we need to introduce these parameters into the traffic light faces. We know we have 8 different traffic light faces, 4 for one and 2 each. So we're going to be introducing each and every one of them into those faces. And after doing that, then we can now run the optimization experiment to see what we'll have at the end of it. So this is the first point of the traffic light. Click on it, go under the properties. So at this point, I click on the first one, then it can be the P1. For the second one, P2. For the third one, we have P3. Fourth one, P4. So 1, 2, 3, 4, we've been able to set that up. Then we move to the traffic light 2. So this first one here will be the P5, and this will be the P6. Then the third traffic light, we have the P7, then the P8. So being able to change each and every of the faces to the parameter faces we've been able to create. So but before we proceed to run this model, we have to create um a new optimization experiment to be able to test it. So we need to be able to create a new optimization experiment under the model. So we have the experiment, we create a new one to be able to run this model. So we click on the experiments. So here we have the optimization because we want to optimize based on the new parameters we've been able to create, which is the optimization. Then click on finish. So with the optimization experiment here, we can still see the time is still there, 10 minutes, which is still set. And when we check out the parameters, we'll see that the new parameters we have been able to create is what is there now. Here are the new parameters we have, that is 1 to 8. So we need to change each and every one of them to discrete. So after doing that, then the number of minimum seconds to spend in the model should be around 10. Then the maximum, you can set the maximum for around 35 with a steep of 5. So here we have it. So the objective is to be able to minimize, and based on that minimization, we need to set the objective, that is the route at which we want to minimize. So here we have the fixed. We've been able to set this, in which we're done with the parameters. Then let us set the route. So we have the route, which is the main itself. Then based on the time in model, so we the route is the model, the route itself is the main, the time in model is the based on the histogram data we're making use of, and we're trying to find the mean. So that is the mean, to minimize the mean. So with all this being set, I think that should be all. Then the next thing we are going to do is to create the default DUI. So this is what the default DUI looks like. So at this point, we would be able to, when we run this optimization experiment for 10 minutes, in which we've already been able to set, after we show the best possible parameters that we can use for that model. So let us go ahead and run this optimization. Here is the optimization experiment. So when we give it few seconds, we start seeing some of the values popping up here, and this will be running for 10 minutes. So at this point, we have to be a little bit patient. So at this point now, that there is now an active iteration. So we have about 28 integrations completed, and it has been able to detect about 23, which is still quite good out of them. And the objective from here, we have about 59 seconds. Here we have it to 45, and there is still movement within the parameters. The parameters still keep changing because it's still running. This will run for about 10 minutes, since that was what we said at the beginning. We're going to be setting it for 10 minutes. So at the end of the day, after running this for 10 minutes, then we'll be able to determine or decide the best possible parameters that we can use on that particular road network. So what we set was just, okay, based on our parameters, we set 30 seconds at a piece for each and every of the phases. But getting to run this with different forms of iterations completed gives us the best possible parameters or the best possible second phases that we can set for each of our traffic light phases in order to maximize the movement of vehicles on that particular road network. So all these things are based on the level and the type of traffic lights we've been able to set, the number of vehicles coming in, all things being equal that we've been able to set in. The moment we decide to change the type of traffic light for a particular point, then it changes the optimization parameters. So whatever best possible parameter seconds or parameter duration we're going to be getting here is based on the kind of road network and the traffic phase we have been able to create. We cannot use the same parameters we get here on another road network. It doesn't work that way. But because of the kind on the type of road network we have presently in this model and the type of traffic light customization that we have been able to do. Now, whatever custom optimization or the parameters, the best possible parameters we're going to be getting out of this is based on what we have been able to create. So let's just hold on for a while. So for this to run for the 10 minutes, then after that we'll get the copy. Here we have the copy best. So, but we can't do that now until we know that we are done with the iteration. So at this point we can see finished. So that means it has been able to run for 10 minutes in which we set. And here we now have the copy best. You can see all the possible seconds for each of the parameters. It has all changed: 15, 10, 10, 10, 25, 30, 15, and 10. So you can just could copy this. So you say allow. So after copying this, then itself. So here we have our main page. So what we copied, we'll now paste it in our simulation, the main simulation we have. So this is what we had before. So copying this new one in now. So all we just need to do is paste from clipboard. So after pasting, it will introduce the ones we copied from that optimization experiment we're able to carry out. Then after doing that, then we can run this simulation. So running the simulation will help us to know when we had it at the beginning, we had about 50, I think 54.3 seconds as the average time spent in the model. So let's hope that with this introduction now, if it will actually reduce the mean time spent in the model. So let us go ahead and try this. So here it is. So we can just scroll down a little bit. So at this point, this is where we'll see the new mean time spent in the model, but we're still running, so you can decide to increase to speed it up. You can see the movement, vehicles coming in, out. So these are all the parameters. So just trying to speed up the whole process. So at the end of this, or after when we've been able to run this to the end, we'll be able to see the the mean time spent in the model, the minimum, the maximum, and also the mean time spent in the model. So the Okay, so at this point we can say finished. So it has been able to run for 10 minutes that we set. Now let's see if what we had at the beginning when we had about 54.3 seconds mean time. Let's see if it has reduced or increased. So we can see at this point we have the mean is now 41.3 seconds. That is about 41 seconds. Then the minimum time is still about 10 seconds, which was what we had initially, and the maximum time has reduced also. What we had at first was about 174 seconds, but now it's 112 seconds. But the major one is the mean time the vehicle or the car spent in the model has reduced from 54.3 seconds to 41.3 seconds. So that is a sign that the new parameters that we introduced into the model will actually reduce the mean time those vehicles spend, and which will bring about more efficiency in the flow of traffic in that particular model. So this is what we call the so in this video we've been able to introduce the traffic light and also how to optimize the traffic light in the model. So thank you.